Welcome to my YouTube channel. Today we'll be discussing sum of geometric progression. If I say sum of geometric progression, if I say sum of GP, I'm still referring to sum of geometric progressions. If you have been following this series, we've been able to iron out arithmetic progression, we've been able to iron out sum of arithmetic progression, we've been able to iron out geometric progression itself. If you have not seen these videos, kindly check this YouTube channel. It will refresh your memory. So we will be concentrating our efforts on sum of geometric progression for this particular video. As you can see on the screen, in our previous videos we've been able to iron out what A means is our first term, what R means is our common ratio, and N is our number of terms. So Sn is our nth term for sum of GP. So if you have not seen those videos, kindly check them out. Now let's dive straight into business. If you are asked to look for the sum of a geometric progression, there's one particular thing you first of all need to look out for is your common ratio. Now, if your common ratio is less than 1, you are going to be making use of this formula. But if your common ratio is greater than 1, you'll be making use of this formula. The difference there is just that if it is less than 1, your common ratio will be on this side. But if it is greater than 1, your common ratio will be on this side. So just take note. So first thing first, look out for your common ratio and check if it's less than 1 or equal to 1. That will make you to know which of these two you will use if you are solving sum of geometric progression. So let's dive straight into question. We have two questions here. The first question says, determine the sum of the first 7 terms of the series. Now, like we've said before, in geometric progression, getting the common ratio involves you. It's either you are multiplying what you have with to get the second term, because this is the first term, this is the second term, this is the third, fourth, we have to get the 7th. Or, now what I do advise is, just take your second term, divide it by the first term, keep your answer. Take your third term, divide it by the second term, you will see that your answer is the same. Take your fourth term, divide it by the third term, you see that, so that is your common ratio. Because if you multiply that common ratio with this, you will get this. If you multiply it with this, you will get this. So let's see. If you say 0.75, so we want to get our common ratio now. Divided by 0.25, you should have 3. Because you say 0.25 times 3 should give you 0.75. If you say 2.25 divided by 0.75, you have 3. Because if you say 0.75 times 3, you have 2.25. If you say 6.75 divided by 2.25, you have 3. Because if you say 2.25 times 3, it will give you 6.75. By implication, it means your common ratio here is 3. So let's dive straight into solving the question. So, first thing first. Let's see what we can do. So with this, let's say our let's work with this. Let's say solution number 1. I want us to still maintain it so that we can see this our series. Now, our first term here has been established to be what? 0.25. So that's the first term. I want us to take notes and pay full attention. Now we've been able to get our common ratio to be what? To be 3. We've ironed that out. But the question is asking us to look for what? The 7th term, that's the N. N to be what? 7. Beautiful. We've been able to iron that out. So we can now apply our formula and solve for the 7th term. But one more thing. We are told that our common ratio, this 3 now is greater than 1. So we'll look for, so we'll say since Since our R is greater than 1, so we can now make use of the formula that we have up there. So let's just put it this way. Since our R is greater than 1, because this our R now has been established to be 3. Definitely 3 is greater than 1. We'll be making use of this. Beautiful. Our R is greater than 1, so we'll be making use of this. So we just impute all our parameters in there. So we know our R now to be what? To be 3. We know our N to be 7. We know our R to be what? 3. And we know our first term A to be 0.25. Beautiful. Having done that, our job is almost done. So with this, if you say 3 minus 1 will give us what? 2. Awesome. If you say, now the next thing for us is to say 3 raised to power 7. If you say 3 times 3 times 3 times 3 into 7 places, so we are multiplying it. That's the meaning of 3 raised to power 7. So 3 raised to power 7 will give us 2187. 2187. Awesome. So what we just need to do is just to subtract this from 1. It will give us 2186. Beautiful. So we just multiply what we have up here. So if you multiply 2186 times 0.25, it will give you what? 546.5. 546.5. Beautiful. If you just divide it, you have 273.25. It's as easy as that. Just for you to get your common ratio and identify the formula to use, you are good to go. So let's go straight to the second question. So let's say solution 2. This is the question. Find the sum of the first 9 terms of the series. So your first term is 72, your second term is 57.6, your third term is 47.08. Mere looking at this, you know that your R will be less than 1. Okay, let's check. If you bring out your calculator and punch, you know, like I told you, the method I'm using, I think it will be easier. It's just to take your second term, divide your second term by first term, divide your third term by second term, you get the common ratio. Okay, let's bring out our calculator and punch. 57.6 divided by 72 to give us what? 0.8. 46.08 divided by 57.6 to give us what? 0.8. By implication, that means our common ratio is 0.8. So let's bring out our parameters. So this time around, our first term is 72. We've been able to establish that our common ratio is what? 0.8. then we have to look for the what? The 9th term. Beautiful. Like our first term here is what? 72. Our common ratio is 0.8. We have to look for the what? For the 9th term, for the first 9th term. Okay, let's bring out our formula. Now we've been able to establish, let's quickly check something, that our common ratio here is less than 1. 0.8 is less than 1. So we look for the formula. So this is what we are going to use. R is less than 1. So we'll come here and say, since R is less than 1, we are going to be making use of this first one. Beautiful. Awesome. So since R is less than 1, this is what we are going to be making use of. So let's impute our parameters. We have our R now to be what? 0.8. So we have our N to be what? 9. We have our R to be what? 0.8. And we have our first term to be what? 72. Awesome. So that means we have successfully input all our parameters into our formula. Having done that, so we can now say 1 minus 0.8 will give us 0.2. This will give us 0.2. Awesome. So if we say 0.8 raised to power 9, that means you are multiplying 0.8 into 9 places. 0.8 times 0.8 times 0.8 times like that until it is 9. So you have 0.1342. 0.1342. Beautiful. So if you now say 1 minus 0.1342, you have 0.8658. 0.8658. This one has gone. Beautiful. So if you now multiply 0.8658 times 72, you should have 62.3376. 62.3376. Awesome. Then if you divide this by 0.2, you have 311.7. Awesome. Awesome. So that's the final answer. That's the 9 terms of the series. You can always pause, rewind this video for better clarification and understanding. Please, if you have any issue with any of our videos or this one in particular, or you have any question, kindly drop it in the comment section. We are going to reply you as soon and as fast as we can. Kindly help us like this video and also help us to subscribe to this YouTube channel, My Simple Maths. And don't forget to help us to on the notification so that you can always receive notification from us whenever we post a new video. Thank you.